All right, let's talk. You're standing in front of a milling machine. It's a heavy, solid piece of iron that can turn a simple block of metal into a perfect, precise part. Or it can turn it into a piece of scrap in about 2 seconds. The difference between the two? It's knowing what's really happening when that cutter touches the metal. So, let's get into it. Sooner or later, this is going to happen to you. You pull a part off the machine and just look at that surface. It's awful. It's got waves, ugly marks, just a terrible finish. You did everything the drawing said, so what happened? Why does it look so bad? Well, I can tell you right now, it's probably not because your cutter is dull. It's something much more fundamental. Here's the first thing you've got to burn into your brain. Milling isn't just about cutting. It's a constant battle against vibration. Every single time one of those cutting edges takes a bite out of the material, it creates force, a lot of force. And that force is trying to push the tool and the part away from each other. Your job, your entire job, is to win that battle. Remember that terrible finish we just saw? Well, that's what it looks like when you lose the battle. That's the physical evidence of vibration that's totally out of control. We've got a name for it: chatter. It's the tool literally bouncing off the workpiece hundreds of times a second. It destroys your part, it wrecks your cutter, and it sounds absolutely horrible. You control the vibration, you control the cut. It's that simple. And here's the thing you have to understand. Everything is connected. If just one little thing in your entire setup is loose or weak, the whole system fails. You could have the heaviest, most expensive machine on the planet, but if your workpiece is not clamped down tight, you're not making parts. You're just making noise and scrap metal. A perfect part has to start from a rock-solid foundation. So let's talk about that foundation. How do we build a setup that's tough enough to win that fight against vibration? The best way to think about it is like a chain. Every single link in that chain has to be strong or the whole thing just falls apart. And this is your chain of rigidity. It starts with the machine itself. All that heavy cast iron is there for one reason: to soak up vibration. Next, your vise. It needs to be bolted to the table so tight it feels like it's welded on. Then the workpiece in the vise. It cannot have any room to move, period. The tool holder, it has to be perfectly clean. One tiny little chip of metal in that taper and your tool's gonna wobble. And finally, the tool itself. Look, the more it sticks out, the easier it is for it to bend and vibrate. Keep it as short as you possibly can for the job. Okay, so your setup is solid as a rock. Now you have to make a choice. And it's a really important one that most beginners get wrong. It's all about which direction you're going to feed the material into that spinning cutter. Getting this right is the difference between a beautiful, clean cut and a shattered end mill. There are only 2 ways to go. We call them up milling, or conventional milling, and down milling, which some people call climb milling. In up milling, see how the cutter spins against the direction you're moving the table? But in down milling, the cutter is spinning with the feed. It's trying to climb right over the workpiece. Now, that might not seem like a big deal, but on a manual machine, trust me, it's everything. Let's look closer at up milling. As that cutter spins against the feed, it's always pushing the table and your workpiece away from it. This is a good thing. It keeps constant pressure on the machine's lead screws and gets rid of any slack or wear, what we call backlash. It makes the cut smooth and stable because you're always pushing against the cutting force. You're in control. But now let's look at down milling. Here, the cutter bites down and it actively tries to pull the table along with it. Now, if there's even a tiny bit of backlash in those screws, the table will suddenly jump forward. When it jumps, the cutter grabs way too much material, takes too big of a bite, and bang! Your end mill shatters into a dozen pieces. This right here is the big aha moment for every new machinist. So here's the hard and fast rule. On a manual milling machine, which always has at least a little bit of backlash, you must use up milling. Just do it. It's safer, it's more predictable, and it keeps you in complete control of the cut. All right, your setup is rigid and you're cutting in the right direction. The next step is getting your speeds and feeds right. And for now, I want you to forget about all the charts and the formulas. The best machinists, they don't just rely on numbers. They listen, they feel the cut. You know, every cut you make has its own sound. It has a certain feel that comes right through the hand wheel. The machine is literally talking to you. It's telling you if things are going well or if something's about to go wrong. Your job is to learn how to speak its language. And these are the signals it sends you.
If you hear a really high-pitched squeal and you see the chips coming off or blue from the heat, your spindle speed is just way too fast. Back it off. If it sounds like the tool is just rubbing against the metal instead of sharing it, your speed's too low. If the whole machine starts to groan and the motor slows down, well, you're feeding way too hard. But if you hear that loud, violent hammering sound, that's chatter. And when that happens, don't even bother touching the speed or feed. Go back and fix your setup. Something isn't rigid enough.
So the final piece of this whole puzzle has nothing to do with the metal and everything to do with you. Being a professional isn't just about making good parts. It's about your habits. It's about respecting the machine and respecting yourself. And that means working clean and, most importantly, working safe. I need you to look at this and burn it into your memory. That spinning spindle has an incredible amount of torque, and it will not stop for anything. It doesn't know the difference between a piece of steel in your hand. There is no emergency brake for your fingers. There's only prevention. These are not suggestions. These are the absolute rules of our trade. Safety glasses on your face every single time. Before you hit that green button, you double-check that your part and your tool are tight. You keep your hands a mile away from anything that's moving. You need to adjust something or take a measurement, you stop the spindle first, and never ever use your bare hands to wipe away those sharp metal chips. That's what a brush is for. These habits will keep you in one piece for your entire career. So after all this, what's the big takeaway? It's all about control. Control over vibration with a solid setup, control over the cut by choosing conventional milling, and control over yourself and your habits to stay safe. Once you master these things, you stop just being someone who runs a machine. You become a machinist, someone who can predict what's going to happen and make it happen perfectly every single time.